All right, so in the last section, we talked about increasing and decreasing, and this is where we're at. To find the intervals where it's increasing and decreasing, we set the first derivative equal to 0 or does not exist, and then we draw our derivative number line. Now, the deal is in this next section, we are going to be talking about a concept known as concavity, and there's two characteristics. You can be concave up or concave down. So this is going to be our concavity test or test for concavity. Now, when we talk about this concavity test, you are going to see that you are going to work only with the second derivative. But what we're going to do with the second derivative is very, very similar to what we did with increasing and decreasing. Just like with increasing and decreasing, we're going to set the second derivative equal to 0 or does not exist. So it's going to be a derivative equal to 0 or does not exist, but this time with the second derivative. And we're going to draw the number line for the second derivative, and we'll plug in a number to the left and to the right of that number line. Now, here is where it is really important to remember that the plus minus that you get depends on which derivative you're plugging into. So if I plug into the first derivative and I get a positive, that positive into the first derivative tells us that we are increasing, that we're going up the hill. Whereas if I get a negative with the first derivative, that tells us that we're decreasing, that we're going down the hill. What's going to happen with our test for concavity is we're going to look at the second derivative, and this time when we get a positive, that positive on the number line, because we plugged into the second derivative, is going to tell us different information. Specifically, a positive second derivative, if that second derivative is positive, that's going to tell us our function is known as a concave up function. So I usually abbreviate that with CU for concave up. Now, what does that mean? A concave up function means that it has some portion of a U shape to it. Now, we don't know exactly like what U we're going to have. We might have a full U for a concave up function, or we could have just a portion of the U function graph. So for example, I could have just this, or I could have just this, or I could have a big loop like this. That would all be concave up. So again, you might not see the full U. You might only see like half of a U or a portion of that U-shaped graph, but all of these would be concave up. And we'll talk about how that means that our second derivative is positive. So when we're doing our number line and we get a positive for the second derivative, that does not tell us increasing or decreasing. That positive tells us concavity. It tells us that it's concave up. So we can write like a little CU, or we can write a little U-shaped graph, but there's some portion of a U-shaped graph on that interval. Now, if we get a negative for our second derivative, that second derivative being negative tells us that the function is concave down. And when you have a concave down function, you have an upside down U. So you have the U inverted. So again, there's lots of variety in what you could potentially see. You could see the full upside down U, or you could see just a portion of it. So something that looks like this would be concave down, or something that looks like that would be concave down. All of those are concave down. So it doesn't have to be the full upside down U. It could be just a portion of the upside down U. Now, again, when we get that negative for the second derivative, that tells us that it's concave down. So there's two things that I want you to take away from this note page. The first is we're seeing a very, very similar process to what we did in the last unit. We're going to be setting a derivative equal to 0. We're going to be drawing a derivative number line. Now with concavity, we're going to be looking only at the second derivative, and we're going to be kind of repeating this process, but now with the second derivative. So setting the second derivative equal to 0 and then drawing the derivative number line. The second takeaway is the information that we're getting from this. When our second derivative is positive, that tells us we're concave up. Again, that's a U-shaped graph. We could have the full U or we could have just a portion of the U. And if we get a negative, that tells us our derivative is concave down, and we could have an upside down U or just a portion of the U.